Hey there, space lovers. Today we're going to talk about the universe's ultimate speed limit, the speed of light. Have you ever wondered if we could somehow travel at light speed? How far could we actually get in a human lifetime? And more importantly, would we have enough time left to come back home? While we're hunting for answers to these questions, we'll wrestle with some physics rules and maybe figure out once and for all why Einstein is such a big deal. So first things first, let's wrap our heads around just how fast light speed actually is. Light travels at about 186,000 miles per second. What does that mean? Well, light could go around Earth 7.5 times in just 1 second. If you could drive your car at that speed, going from London to Paris would take... Wait, never mind doing the math. You'd already be there before time even had a chance to pass. But why is this speed so special anyway? According to Einstein's theory of relativity, the speed of light is the absolute speed limit of the universe. Nothing can go faster than light. This isn't just some random rule. It's a fundamental property of how our universe works. It's like the universe is a video game and the developers hard-coded the maximum speed limit at 186,282 miles per second. Now let's get to the real question. Is light speed travel actually possible? Theoretically speaking, the answer is both yes and no. Confusing. A little bit. Einstein's special theory of relativity tells us this. Nothing with mass can reach the speed of light. Why? Because as you speed up, your mass increases, and as you approach light speed, your mass approaches infinity. Moving infinite mass would require infinite energy, which is obviously impossible. But wait. This isn't all bad news. Getting to 99% of light speed, or even 99.9%, is theoretically possible. Of course, we'd need way more power than our entire galaxy produces. It's like your phone battery is about to die, and your charger is in another galaxy. Now, what about massless particles? Photons, the particles that make up light, already travel at light speed. That's their normal speed. But since us humans have mass, instead of reaching light speed, we should focus on getting really, really close to it. All right, math time. Let's say the average human lifespan is 80 years. If a human could spend their entire life traveling at light speed, they could cover a distance of 80 light years. How far is 80 light years? Our nearest star, Proxima Centauri, is 4.24 light years away. So getting there and back would take 8.5 years, leaving us with 71.5 years to explore even further. Sounds pretty awesome, right? But here's an important detail. 80 light years is actually a tiny distance on a galactic scale. Our Milky Way galaxy is about 100,000 light years across. So in one human lifetime, we could only explore about 1,000th of our galaxy. This might sound disappointing. But remember, our galaxy has 400 billion stars. Here's where things get really interesting. According to Einstein's theory of relativity, as your speed increases, time slows down. This is called time dilation. If you travel at 99% of light speed, time passes much slower for you compared to people who stayed on Earth. For example, when traveling at 99% light speed, while 1 year passes for you, about 7 years pass on Earth. What does this mean? If you take a 10-year space journey and return to Earth, you'll find a world that's aged 70 years. Your friends might be the same age as your grandchildren. In this situation, distances also shrink for the traveler. This is called length contraction. A trip to a star 40 light years away might only take you a few years, but 80 years would have passed on Earth. It's like the universe has a cheat code that only fast travelers can use. Now let's get into some concrete examples. Say you're a 40-year-old astronaut who can travel at 99% light speed. Round trip to Proxima Centauri takes about 1 year of your life, but 60 years pass on Earth. You come back at 41, but your kids have aged 60 years. Trip to Vega, 25 light years away. Round trip takes about 7 years of your life, while 350 years pass on Earth. When you return, nobody you knew might still be alive. Trip to the galactic center, 26,000 light-years. Now this would be a really bold choice. It would take about 20 to 25 years of your life, but 52,000 years would pass on Earth. Coming back to see how human civilization evolved, that could be pretty mind-blowing. If you spent 40 years traveling to the furthest point, you could reach about 2,000 light-years away. There are thousands of star systems at that distance, but you'd need another 40 years for the return journey. Here's the biggest problem we face. If we want to come back, we need to spend half our lifetime going and half coming back. In an 80-year lifespan, that's 40 years out, 40 years back. This means we can only go a maximum of 40 light-years away. But we have to make a choice here. Do we want a long exploration, or do we want to come back and tell our story? If you buy a one-way ticket, you could go 80 light-years away and start a new life there. Of course, you'd never see your loved ones on Earth again. Another option is the generational ship concept. You start the journey as a family, have kids during the trip, they have kids. So your grandchildren reach the destination. Romantic? Maybe. Practical? Questionable. Of course, near light-speed travel isn't just theoretical. It has practical challenges too. First, there's the energy problem. Getting just one human to 10% of light speed would require more energy than the entire world uses in a year. Then, there's the radiation problem. When traveling at high speeds through space, every hydrogen atom you encounter becomes a high-energy radiation source. It's like being under constant X-ray bombardment. And there's the stopping problem. When you're going at 99% light speed, how do you stop? Braking requires just as much energy. It's like driving 120 miles per hour on the highway and suddenly realizing your brakes are broken. For realistic approaches, 1 to 5% of light speed seems more reasonable. Travel times get longer, but energy requirements become more manageable. Getting to Proxima Centauri at 5% light speed would take 85 years. One human lifetime. But at least it's technologically imaginable. So in conclusion, even if we could travel at light speed, we'd still be pretty limited when faced with the vastness of the universe. In one human lifetime, we could only visit our close neighbors. But that's not a bad thing at all. Within a 40 light-year radius, there are thousands of stars. Each one potentially hosts planetary systems. Sometimes the greatest adventures are found in the closest places. Maybe the real question should be, when we master light-speed travel, what questions will we be looking to answer? Are we alone? How did life begin? Are there other civilizations out there? For these questions, even a 40 light-year area is more than enough for one human lifetime to explore. Because sometimes what matters isn't how far you go, but what you discover along the way. All right, folks, light-speed travel might be possible in the future, but for now, let's keep dreaming, because today's dreams become tomorrow's reality. If you enjoyed this video, don't forget to hit that like button, subscribe to my channel for more space content. Let me know in the comments what space topic you're curious about. It might be the subject of my next video. See you in the next video. And don't get lost in the depths of space.